Welcome. In this video, we're going to introduce a measure of spread called standard deviation, and we're going to perform a calculation to calculate standard deviation. So we'll start with a definition here called the deviation, and it's how far your entry is from the average. So if you think about how tall you are, you're one member of the data set for the heights of all the people. And then there's an average height, and you might be the average height, but more likely than not, you're not the average height. So if you subtract from your height the average, then you'll get what's called the deviation. So if you are taller than average, then your deviation will be a positive number. It'll be just how much taller you are than the average. If you're shorter than average, then your deviation will be a negative number. It'll be how much less you are than the average in height. Now the variance is a measure of spread, and it'll be an intermediary for us calculating standard deviation. And what it is it's a type of average. It's an average of the squares of all the deviations. So really, this is excess information. It's an average of the squares of the deviations. So you take all these deviations, you multiply them by themselves, you add them all up, and divide by how many you have. So let's see what that looks like in practice. So we have an example here. It's our sleeping example, and we want to calculate the variance. So I'm gonna transpose this table so we're gonna deal with columns. So you'll have your number and the distribution. So we'll have your 8, 8.5, 6, 9, 7.5, and 7 again. And then we'll have our deviation. So this is going to be how far each number is from 7.7, which is our average. So 0.3, 0.3, 0.8. These are I'm doing 8 minus 7.7. 6 minus 7.7 is negative 1.7. 9 minus 7.7 is 1.3. 7.5 minus 7.7 is negative 0.2. And 7 minus 7.7 is minus 0.7. Now we need the deviation squared. So all of those numbers multiplied by themselves. So it's be 0.09. That's 0.3 squared. I guess this is 8 minus 7.7. This one's going to be the same. 0.8 times itself is 0.64. Just do 8 times 8 is 64, and then you have to move the decimal place over twice. 1.7 squared. 1.7 times 1.7. That one's 2.89. And notice I didn't do the minus signs. Maybe you're keeping track of those. But a negative times a negative is a positive. And so that's actually the reason why we're squaring these to begin with, is to get rid of the minus signs on the deviations. And we'll have 1.3 times 1.3. If you remember your times tables, 13 times 13 is 169. So 1.3 times 1.3 is 1.69. We're going to have a negative 0.2 times negative 0.2 will be 0.04 and 0.49. Now, variance is just the average of these numbers. Of these. It's like from our original data set over here, it's like we produced a new data set. And this new data set represents how far the individual items in the original data set were from the average. And they do it with all positive numbers. And we achieved all positive numbers by squaring. So that was the desired effect. And then let's add those numbers up and divide by how many there are. 0.64. Okay. Sum is 5.93. So average is 5.93 divided by 7. 0.8471. Great. And then finally, let's scroll down a bit and let's talk about the standard deviation. The standard deviation is the square root of the variance. So we'll take that number, which is the variance, and take its square root. There's some typical notation as this funny little Greek letter called sigma, lowercase sigma. I guess it's not really funny, it's only unfamiliar. Funny, lowercase sigma, Greek. Greek's probably a capital letter. Is this, kind of looks like a sideways 6. You could practice drawing it if you felt up for it. But variance is denoted with the sigma squared, and the sigma by itself is standard deviation. And then we'll just make a remark here that the reason why we square root the variance is to get the number back into units of the original variable. So if you go back up to 0.8471, this is in hours squared. And that doesn't really make much sense as a time unit. What does this mean? And so in order to get a number that is related to the original list of numbers, we need to take the square root. And we're in hours squared here because we squared all of those differences, all those deviations. So we just need to do this final bit, standard deviation equals square root of variance equals 0.8471 equals, and let's just bring our little calculator back, square root 0.8471, 0.92, 0.92. And what this means is, on a typical night, you sleep, average was 7.7. Average hours slept, 7.7. And the standard deviation is 0.92. These two numbers together give you a more complete picture of the distribution of the hours you sleep per night. So typically you sleep about 7.7 hours, but give or take 0.9 hours. So if you slept 6.6 in one night, or 6.8 in one night, or 8.6 in another night, it wouldn't be that surprising. The standard deviation is communicating, hey, how far away from the average is typical. So that's a calculation of standard deviation. In the next video, we'll do a little bit more on interpreting it. See you there.